Hello everyone. Today we are going to find the eigenvalues and eigenvectors of this matrix. Let us keep this matrix as A. We know that the characteristic equation of a 3 cross 3 matrix is lambda cube minus s1 lambda square plus s2 lambda minus s3 is equal to 0. S1 is the sum of the diagonals. Here we have the diagonals 2, 2 and 2. When we add the three of them, we will get 6. S2 is the sum of the minors along the diagonals. First, let us take this diagonal. We have to cut the row and the column. The remaining is 2, 0, 0, 2. Now let us take this one. We have to cut the row and the column. The remaining is 2, 1, 1, 2. Now let us take this diagonal. We have to cut the row and the column. The remaining is 2, 0, 0, 2. 2 into 2 it will be 4 minus 0 into 0 it will be 0. 4 minus 0 we will get 4. 2 into 2 it will be 4 minus 1 into 1 it will be 1. So we will get 3. 2 into 2 it will be 4 minus 0 into 0 it will be 0. So we will get 4. When we add these 3 we will get 11. S3 is determinant of A. 2 into we have to cut the row and the column. We have 2, 0, 0, 2. Then minus 0 into we have to cut the row and the column. But when we multiply any value with a 0, it will be 0 only. So no need to waste the time. We can just write 0. 1 into we have to cut the column and the row. The remaining is 0, 2, 1, 0. 2 into 2 it will be 4. 4 minus 0 it will be 4. So 2 into 4. 0 into 0 it will be 0 minus 1 into 2 it will be 2. 0 minus 2 it will be minus 2. For S3 we will get 6. In this equation let us apply the values of S1, S2 and S3 so that we will get this equation. Now we are going to find the eigenvalues. The eigenvalues are the roots of this equation. We need to find the roots. For lambda, first we have to apply minus 1. We have to check whether the equation becomes a 0. If not, then we have to apply 1. Then we have to apply minus 2, then 2, and it goes on. When we apply minus 1, the equation does not become 0. We are getting minus 24. When we apply 1, we are getting 0. So 1 is the root of this equation. We have to find the other two roots also. Using the first root, we can make the 2-degree equation. Here we have 1, here minus 6, here 11, and here minus 6. Here we have to apply 0. 1 plus 0, it will be 1. 1 into 1, it will be 1. Minus 6 plus 1, it will be minus 5. 1 into minus 5, it will be minus 5. 11 minus 5, it will be 6. 1 into 6, it will be 6. Minus 6 plus 6, it will be 0. So we can write this equation as lambda minus 1 into lambda square minus 5 lambda plus 6 is equal to 0. From this equation, we have to find the two roots. When we add two numbers, it should be equal to minus 5. And when we multiply those two numbers with each other, it should be equal to 6. When we add minus 2 and minus 3, it will be equal to minus 5. And when we multiply minus 2 with minus 3, it will be equal to 6. In this way, we can write this equation as lambda minus 2 into lambda minus 3. So for lambda, we will get to 1, 2 and 3. So the eigenvalues are 1, 2 and 3. We have found the eigenvalues. Now we are going to find the eigenvectors. To find the eigenvectors, we have to solve these. We know the A matrix. Inside the A matrix, we have to subtract lambda by the diagonal members. In this way, we will get A minus lambda I. We know that the size of this matrix is 3 cross 3. So instead of x, we have to apply a matrix with the x1, x2 and x3. When we multiply lambda with the identity matrix, we will get this. A minus this matrix, we will get this. So no need to do this step. We can directly make this matrix. First, let us find the eigenvectors using lambda is equal to 1. 2 minus 1, it will be 1. Then we can multiply the rows with this column so that we will get these three equations. To solve these three equations, we are going to use Cramer's rule. We have to select two equations from these three. When we select, we have to be very careful. You can see that in the first and third equation, all of the values are same. In this case, we should not select these two together. We can select either these two or these two. I am going to select these two. Let us see how to use Cramer's rule. First, we have to write x1 upon. We have to cut x1 from both of the equations. The remaining are 0, 1, 1, 0 is equal to, with x2, we have to apply a negative sign. Then we have to cut x2. The remaining are 1, 1, 0, 0 is equal to x3 upon. We have to cut x3. The remaining are 1, 0, 0, 1. 0 into 0, it will be 0, minus 1 into 1, it will be 1. 1 into 0, it will be 0, minus 0 into 1, it will be 0. 0 minus 0, it will be 0. 1 into 1, it will be 1. Minus 0 into 0, it will be 0. In this way, we will get the corresponding eigenvector x1 is equal to minus 1, 0 and 1. Now let us find the eigenvectors when lambda is 2. 2 minus 2, it will be 0. Then from these, we can form these three equations. Now we have to select two equations. You can see that in the second equation, all of the terms are 0. So we should not select these. Only we have to select the first and third equations. x1 upon, we have to cut x1. The remaining are 0, 1, 0, 0. Minus x2 upon, we have to cut x2. The remaining are 0, 1, 1, 0. x3 upon, we have to cut x3. The remaining are 0, 0, 1, 0. After simplifying, we will get the corresponding eigenvector x2 as 0, 1, 0. Now let us find the eigenvectors when lambda is 3. 2 minus 3, we will get minus 1. From these, we can form these three equations. You can see that the first and third equations are same, only the signs are different. Let us take this equation, let us change the signs. No need to consider this one because it is 0. Now you can see that both of them are same. In this case, we should not select these two together. We can select either these two or these two. I am going to select the first two. Finally, for the corresponding eigenvectors, we will get 1, 0, 1. Here you can see the answers. Now we are going to end this session. Thank you for watching this video.